Have you ever wondered why your car's dashboard light glows every time the door is left ajar? Similarly, on closing the door, why does the light go off? These conditional checks are done by basic building blocks of all electronic circuits called logic gates. Large numbers of such gates fabricated together form integrated circuits commonly called ICs. These ICs are widely used in the configuration of electronic gadgets like laptops, gaming gadgets, and digital watches, etc. Let us learn more about the working of logic gates. To begin with, consider an electrical circuit consisting of two switches, A and B, a bulb X, and a battery all connected in series. Let's examine the output of the bulb for all input states of the switches. When both the switches are open, the circuit is incomplete, hence no current passes through the bulb and it does not glow. When switch A is open and B is closed, again the circuit is incomplete and the bulb does not glow. Now, when switch A is closed and B is open, yet again the current does not flow through the bulb and it does not light up. Finally, when both switch A and B are closed, the circuit is complete and the bulb glows. Thus, we see that the output of the bulb depends on the input of the switches and performs a logic operation. That is, the bulb only glows when both switches are closed. This circuit is an analogy of the logic operation of an AND gate, which is one of the basic logic gates. This is the schematic symbol of a two-input AND gate. Switch A and switch B correspond to the two inputs A and B, and the bulb corresponds to the output X. The Boolean expression of the AND gate is given as X is equal to A and B. In digital electronics, the on state is represented by binary digit 1 and the off state is represented by 0. Thus, the input-output information of any logic gate can be tabulated into a table to give a visual representation of the switching function of the system. This is called a truth table and shows each possible combination to the gate with the resultant output. It should be noted that a logic gate can have more than two logic inputs and produces a single output. The possible input combinations of n input logic gate are given as 2 to the power of n, where n is the number of inputs. Hence, a 3-input gate will have 8 input combinations and a 4-input logic gate will have 16 input combinations respectively. Like AND gate, there are two more basic logic gates called the OR and NOT gate respectively. OR gate. This circuit is an analogy of the logic operation of an OR gate. In an OR gate, when inputs A and B are 0, respectively the output is 0. For all other combination of inputs, the output is 1. The schematic symbol of the OR gate is as shown. The Boolean expression of output Y is equal to A or B. The truth table for 3-input and 4-input OR gate are as shown. NOT gate. This circuit is an analogy of the logic operation of a NOT gate. When switch A is closed, the current flows through the closed path and the bulb does not glow. When switch A is open, current flows through the bulb and it glows. NOT gate is also known as an inverter as it complements the input. Thus, an output 1 is obtained for an input 0 and vice versa. The Boolean expression of output Y is equal to NOT A. We will learn more about the combinational circuits that are obtained by using these basic logic gates in our next modules. Summary: logic gates are the basic building blocks from which the digital systems are built up. The basic logic gates are AND gate, OR gate, and NOT gate. A logic gate performs a logic operation on a set of inputs and gives a single output. In digital electronics, the ON states represented by binary digit 1 and OFF states are represented by 0. A truth table shows each possible input combination to the gate with the corresponding resultant output. The possible input combinations of n input logic gate are given as 2 to the power n, where n is the number of inputs.